Hello friends, hi. I hope all of you are doing very well. So today I'm very excited because today is the day of Lok Sabha election results, which is something which is good for all of us, which is something very special for all of us being the Indians. So I hope that whichever government comes for the next 5 years, they serve us very well and we are being able to feel that yes, we are in safe hands and the government also understands its responsibility and find that yes, this is the need of the people and this is what we need to do. We have a certain good plan, and based on that, we can make a bright future of India altogether. So, hoping this, let's start with our today's session. You must be knowing that in our previous session, we talked about some of the questions related to that of thermochemistry. So, in this session, again, I'm going to take you to another 5 questions of thermochemistry so that we can understand this topic even better. Although the previous questions that we discussed, they were more based on enthalpies of combustion and enthalpy of formation. We will see some new more concepts here, and I will try to make thermochemistry something very, very good to you and something in which you can feel very confident at the end of all these 17 questions that I have in my hand. Okay, so let's start with this session. I don't want to take much of your time. Here I'm sharing the screen with you, and I'm sure the screen is visible to you now. Okay, so the previous 5 questions are already done. So now this is the another question. The enthalpy of combustion of a fuel, okay, what enthalpy of combustion of a fuel, there is some fuel inside, was determined using the calorimeter. Okay, so this is what we have as a calorimeter, and we have a fuel. You can take, this is some spirit burner and we are burning it over there so that some of the burner, which is actually consisting of the fuel, this is a very basic diagram of calorimeter. Okay, it's not like a bomb calorimeter. Don't get confused. Bomb calorimeter is being made in more specific and better conditions. This is a simple calorimeter that you yourself can prepare at your home or maybe in simple labs. So this is a calorimeter. The final result was lower than the literature value. Okay, generally we expect that if it is a combustion reaction, it should be exothermic in nature. We all know this. And if this is exothermic nature, so that means delta H should be negative, and that means that the energy should be released. And the release of energy is generally associated with the increase in temperature. So we were expecting that when we are making this kind of setup, so here we would have been some water into it. We put some temperature probe, or you may say it's a thermometer. So whatever is the temperature of the thermometer earlier when we started this process, there should have been a certain rise at the end of the reaction, at the end of this process, because it's a combustion of fuel. Although this is not taking place in this case. So you have to tell that what could be the possible reasons for this. See, which factor could have contributed to this error? What is the error? That the temperature we are being able to see in thermometer is lowered. So we have this first as option. Not all the heat from the combustion was transferred to the calorimeter. Definitely, this would be one of the reason. Not all of the heat from the combustion, although the combustion of fuel took place, but it might be possible that our setup is not such a good way, or it's not insulated in such a proper way that all the heat from the fuel it has went to the water, so that your thermometer can actually see this. So this would not have been taken place. So yes, this is one possible reason. Incomplete combustion occurred. This is one of the major reasons that you can find this kind of error. So it's possible that the fuel which you are trying to burn, for which you are doing this combustion process, is not being able to get the proper amount of oxygen. So if that oxygen is not there, or if your material is not very fully combustible, so this might be possible that it's undergoing incomplete combustion. So instead of forming carbon dioxide as the product, we may see that some of the carbon monoxide might be forming. Whenever there is carbon monoxide formation, this always results into decrease in the energy. So those kind of fuels which create incomplete combustion and forms the carbon monoxide, they are not considered as the good fuels. Always remember this. So 1 and 2 are obviously the reasons. Now coming on to the temperature probe touched to the bottom of calorimeter. See, this option I won't take it. Why? Because the calorimeter is being designed in such a way that it's being insulated properly. So even if you have a certain base, in general, you might feel that, okay, if I have a container, it consists of some hot material into it, but still the surface might not be at the same temperature. That might be possible if it is an open container or some exposed container. But in this case, case, if you see, this calorimeter has already been insulated. Since it's insulated, it's quite compact. So even if your temperature probe or thermometer is being touching to the surface, this should not create any difference in temperature. I hope this part is clear. So yes, when it comes to decide between 1, 2, and 3, I will go with the option 1 and 2 only. That means A. So this should be my answer. I hope you understood this thing. If you understand the calorimeter, so this might not be a very difficult question to you. But still, if you have any kind of confusion regarding the calorimeter or bomb calorimeter, anything, or you want to know what it calculates, what it does, what kind of setup is there, so yes, please comment me in the inbox so that I can make a dedicated video just on calorimetry. Okay. Fine. Now coming on to question number 7. Which equation shows the enthalpy of formation of ethanol? Okay, enthalpy of formation of ethanol. See, it's enthalpy of formation. So what you need to remember, as we discussed in our yesterday's class, that whenever you are trying to find the enthalpy of formation, so as per definition, always remember that you have to form 1 mole of your product. In this case, my product is ethanol. So 1 mole of ethanol has to be formed from the elements which are there in their elemental state at room temperature. Okay, so the constituents should be in their elemental state. The state in which they naturally exist in at the room temperature or stable state of them is the elemental state. Now coming on to the equation, like how does the equation looks like? So ethanol is what? It's at room temperature, it's liquid in state. I need to form 1 mole of ethanol. Got it? Now, what are the constituent elements here? So carbon, definitely. Carbon in its graphite form is the stable state. That means the solid form. Now coming on to the another element that I should have is the hydrogen. You can see that. So hydrogen naturally exists in the form of hydrogen molecule, which is gaseous in state. Okay, I hope this is fine up to here. Then we can also see that in this formula, we also have one more atom element, which is oxygen. Oxygen too exists in the diatomic state, and this is also gaseous in its form. Got it? Now see, I only need to form 1 mole of ethanol. So let's remove those options which does not form 1 mole of ethanol, because here we are talking of enthalpy of formation where you need to prepare 1 mole of it, then only this will give you the proper literature value. So option number B and option number D are not the correct answers for sure. Okay, now let's see what is the difference between A and C. Of course, you need to balance this equation. Okay, need not to say. So you can see that there are 2 carbons in the ethanol, right? So I can put 2 carbons here. How many hydrogen do I see? I see just 1 hydrogen. So what I may do, I need to change my equation. Oh no, sorry, there are 6, no? So we have 5 here and 1 here. So that means we have hydrogen molecules. So I may multiply this with 3 so that it becomes 6. Okay, nice. Now we have just 1 oxygen, but here I have an oxygen molecule, which is in the form of diatom. So no problem, you just take the half mole of it, no? See, mole is nothing but a number. So if you half it, you will get half number of molecules of it. That's it. Okay. So yes, you can do any kind of thing with the moles. Now coming on to, I can see that there are 2 carbons, 3 hydrogen, half oxygen, and this is 1 mole of ethanol, and this is also 1. Oh my God. So what is the difference among them? Is there any difference or not? No. Let's see their states. So I can see that this is solid, that's perfectly fine. Hydrogen in its gaseous state at room temperature, perfectly fine. This is also gas, this is also gas, which is perfectly fine. But when it comes to ethanol, I can see that ethanol does not exist as a gas. It has a good solubility in water as well, right? It's a liquid. It's not gas, it's a liquid. That makes your option number C as the correct option. Okay, so this is how you are going to see your question. Although when I'm dictating these questions to you, this might be feeling that, okay, this is a long question and this is taking too much of time. But when you actually perform the question and when you have the ideas in your mind, you can just stick it in within seconds. Okay, nice. But I'm just trying to tell you the process, the way that you should think for a question. Now let's move on to question number 8. Which combination will give you the enthalpy change For the hydrogenation of ethene to ethane, that means you need to find out delta H3. I can see delta H3 is here. C2H4 is what? It's ethene, right? And you are doing its hydrogenation. That means you are adding up hydrogen to it so that you can form a ethane. You are preparing an alkane from the alkene. Got it? Now, see, direct information is not given to you. This is what you need to find. But you are being given certain other things based on which you need to find out this whole thing. Now, see, your ethane is being formed by ethene, right? And what reaction is this? Carbon, hydrogen, where I can see carbon and hydrogen, they are in their elemental state. It means that this delta H2 refers to the formation of ethene, right? Nice. Okay. Then coming on to this carbon and hydrogen, in presence of oxygen, they are forming carbon dioxide and 3 moles of hydrogen. Okay, so this seems to be a okay, fine reaction. Now coming on to what is this reaction being showing to you? C2H6 when being treated in presence of oxygen gives you carbon dioxide and hydrogen. It's not water, so this is not a combustion reaction. Be very careful about it. Okay, how to proceed with this question when different kinds of information of different enthalpies are being given? See, for this, the first step that you will do is that you just write down your equation for which you want to find out the thing. I'm not writing down the physical states here, but if you want, you can do so. This will take unnecessary space. That's why I'm not doing it. But yes, you should always write that thing as well when you are dealing with thermochemistry. This is what you need to find out. Okay. Now, write down all the other equations as well. So here the first, let's write delta H1 first. So I can see that this is 2 carbon plus 3 moles of hydrogen in presence of 2 moles of oxygen. You can see the oxygen has been written here on the arrow. This gives you 2 moles of CO2 and 3 moles of H2. Okay. Then I can see the another reaction that is for delta H2, which is 2 carbon plus 3 H2, 3 moles of hydrogen. That gives you C2H4. Got it? And this is what this was your delta H1. This is your delta H2. Nice. Now coming on to the third reaction that I can see, which is for delta H4. This says that C2H6 in presence of 2 moles of oxygen gives you what? This gives you 2 moles of carbon dioxide and 3H2. I hope this part is clear. Okay, and this represents to delta H4. Now see, what you need to do now, that's the most crucial step, I would say. Okay, see, I should have my delta H values on that side. Based on the equation, you will decide whether to arrange the moles or whether to change the signs, what you need to do. See, I can see that my C2H6 on the right hand side, but the 3 equations given to me has C2H6 but on the left hand side. Do you understand? If it is on the left hand side, I need to make this reaction reverse so that C2H6 may arrive on the right hand side. That means whatever is the delta H4 value, I need to take negative of it. Okay, the same way. Now coming on to C2H4. Where is C2H4? See, C2H4 in these given equations, I can see it's on the right hand side. But in the equation that I want to determine delta H3 for, that has C2H4, that means ethene on the left hand side. Again, I need to reverse it. Okay, so when I reverse it, so this will become minus of delta H2. Okay, now then comes your hydrogen. Now hydrogen might be a little problem. Why I am saying so? Because of course in my answers I can see that I cannot talk about this hydrogen. Reason being because I can see in the equation delta H1 thing is also being included. So some way for hydrogen I need to include the delta H1 part, right? So this is not the hydrogen they are talking of. Now which hydrogen to take? This one or this one? Okay, so right, so which one to take? By the way, I can see that these hydrogens are being utilized and they are being coming up. So what hydrogen should I consider here? So yes, so what will you do here? You just take just consider this thing, or you just find this out, like which one is the negative part. First of all, let's cross those options which does not have delta H2 and delta H4 not to be negative. So this could be my possible answer, because I can see delta H2 and delta H4, they are negative. This is wrong because I can see delta H1 is being considered as negative, which is of course wrong. Now coming on to delta H2, delta H1 and minus delta H4, this is also wrong because I can see that the delta H2 is not being taken negative. That makes it wrong. Here I can see delta H4 is not being taken negative, so that means this is also wrong. So we are just left with one of the answer. Although if they give you straightaway equations, you can yourself determine, like you need to arrange your equation in such a way that your delta H1 comes either on the left hand side or right hand side based on the options. You can actually decide that thing. Got it? So this is how you're going to do it. Here, this would have been a pretty much simple question if they would have given you the equations just in a simple way. But because they gave it to you in the form of a chart, or you may say a flow diagram, so this is looking a little difficult. But once you get a little expertise, you will be able to know that how to change the signs of delta H, how to multiply and divide to get the desirable number of moles just by seeing the equation in such a way. Okay, so I'm sure that this would have been a simple question to you for now. Okay, this is something a good question. I really consider this one as a good question. Let's see. What is the hydrogen-hydrogen bond enthalpy in kilojoule per mole in the hydrogen molecule? This is what you need to find. Right? Hydrogen-hydrogen bond enthalpy. This means that if you want to break down the hydrogen-hydrogen bond in hydrogen molecule, how much energy for per mole of hydrogen you need to provide? That's the question. Okay, here you are also being given some delta HF information of water molecule. Let's see how we can utilize this information. First of all, you just write down your equation, which is oxygen, and that gives you 2 moles of water, and they all are in the gaseous state. Got it? Fine. And I know one thing, like you can determine the delta H of reaction based on bond enthalpy as well. And for like when bond enthalpy informations are given, what do you use? You see that how much energy is needed to break the bond. That means here we take the energies of the reactant minus the energy which is being obtained when new bonds are formed. Okay, that means it's for the product. Also, the same delta H reaction can also be found in terms of formation. How do you do that? For formation, what we take? Products minus reactant. So the delta H F, like heat of formation for the products, minus delta HF for reactants. And you can also put it as sum up if you have more than one reactants or products in your equation. Okay, so I hope this part is clear. Now coming on to, let's apply the values to it. So let's first of all find based on the bond breaking and bond making, let me call this as 1. So while you find out the delta H reaction in this case, so for breaking this bond, you can see how many hydrogen-hydrogen molecules you have. You have 2 molecules. So we have hydrogen-hydrogen bond, how many? 2 hydrogen bonds. Here we have just 1 oxygen bond, and here 1 water molecule. If I make a water molecule, so you can see this is my 1 water molecules, and similarly we have 2. In 1 water molecule, you need to break 2 OH bond. So for 2 water molecules, you need to break 4 OH bond, right? So this is simple. Okay. Now you just put the values. So I can write, okay. So this was the color, no? So I can write there are 4 OH bond that will be formed. Got it? Fine. So now it's bond breaking. That means bond breaking of reactant minus the energy which is obtained when the products are formed. So for breaking reactant, you can see 2 HH bonds are being broken, plus 1 OO bond is broken. For 1 OO bond, you can see the value is equal to Y. So let's put this as Y. Minus 4 OH bonds are being formed, and the associated value is equal to Z. So we have 4Z like this. So this is the information I obtained from bond breaking and bond making. Now I can also find out the delta H reaction based on their enthalpies of formation. For enthalpies of formation, I need to do product minus reactant. Although be very careful that this equation is not a heat of formation equation. In order to convert this to heat of formation equation, I should know that only 1 mole of the product should be formed. So if I have to form 1 mole of product, my equation will modify to 1 mole of hydrogen and half of the moles of oxygen. Is that clear? Now rest of the part is fine. Now what do? You already know that the heat of formation of something which is already in its elemental state is equal to 0. So for hydrogen, which is in the gaseous state, oxygen in the gaseous state, so these have the delta HF values equal to, here I'm talking of delta HF values. So they are equal to 0. Why? Because they are already in their elemental state, so you need not to prepare them. But for water, if you see it's being given to you that it's equal to X for 1 mole of water. Okay, now I need to do product minus reactant, right? The heats of formation of product minus heats of formation of the reactant. For product, as we have 1 mole of water, so I'm going to take this as X minus, if you want, you can put it as 0 plus 0, although that does not make any sense, so it's simply X. From 1 and 2, you got the values of delta H reaction from 2 different informations. Now you just equate them. So this will become 2 moles of hydrogen-hydrogen bond if you want to break. So this should be plus Y minus 4Z is equal to X. Okay, let's rearrange this equation. So for 2 moles of HH, this equation will become X minus Y plus 4Z. And for 1 mole of HH, this will become half of X minus Y plus 4Z. Now you may match your answers from the equation given to you. So it's definitely not X minus Y plus 4Z because it does not consist of half of its mole. This seems to be the answer, right? Yes. So B is my answer. Got it? So this is one of the question. You may consider this as a nice question where you need to work, where you need to think that heats of formation is for 1 mole, because I guess this is the only point where you may find some confusion, or maybe the chances of silly mistake is most. Okay, so be careful about it. Okay, this is your question number 10, and this is also something good and different. It's kind of different from the questions we have done so far. A student obtained the following data to calculate the value of Q. Q is what? Q is the heat of reaction, heat. Like how much of the heat is being taken in or how much is being transferred, that thing. And it follows the formula Q equal to MC delta T. We all know this. For M, the value is being given this way, plus minus 0.2 gram. That means there might be certain fluctuations, some error while we are measuring the mass. Delta T is 10 degrees Celsius plus minus 1 degree Celsius. Again, certain uncertainty is there. C is the specific heat capacity, which is of course constant for water. What is the percentage uncertainty in the calculated value of Q? Now, how do you calculate the percentage? See, if I conduct a test of 10 marks and you have obtained 8 marks out of it, if I ask you to give me the marks in percentage, what would you do? 8 by 10 multiplied by 100, which gives you 80%. This is what you do, right? So what is 10? 10 is the most that you would have got, and 8 is the marks that you actually got. This is how we do. So there is an error because this time we want to find the percentage uncertainty. So let's see what is the percentage uncertainty in the mass. So in mass, what is the percentage uncertainty? So it's actually the uncertainty, which is 0.2 divided by the actual mass that you actually expected to be true mass multiplied by 100. You get it? So this is what you need to do. Now, similarly, in order to get the delta T, what you will do, and again, if you want, you can actually make this calculation. Although this is not that difficult, but still I'm using a calculator so that we don't make any mistake. 0.2 divided by 20.2, which is 9.99, and then it's 100. So this is 0.99. Okay, so it's almost 0.99%, which is almost equal to 1%, as you can see. And for delta T, if you want to find out the percentage uncertainty, what you will do, again, the same thing, the uncertainty divided by the value that you actually expected, multiplied by 100, and this comes out to be 10%. So the total uncertainty percentage will be 1 plus 10, that means 11%. Because these are the things that you will putting up into the formula. This is the formula Q equal to mc delta T, right? So because of mass, we can see 1% of uncertainty might be there. And because of the temperature difference, you may see 10% of the uncertainty. C is not contributing to any uncertain value because it's already specific, it's constant, it's been reported, it does not change, right? So it's already constant thing. So your Q and its uncertainty just depends on mass and delta T. Got it? Q and its uncertainty is actually the fraction of mass and delta T and their uncertainty. Got it? So this comes out to be 11%, which is option number C. Okay, so these were some of the questions, and I guess that you would have enjoyed doing these questions. You would have got some idea how to perform the question, how to think. This is very important. The answers are not important. This is not important that you have understood it for now. What is important is that how you think when a question is given to you, what is the process that goes to your mind, and how do you see that question, and how do you make a strategy or plan to perform that question. That's all these classes are all about. But still, if there is anything that you want to ask me, because presently we are talking of thermochemistry, so I would ask you if you have any confusion related to this topic particularly, then we can discuss those things. If you have any specific topic you need a theoretical explanation for it instead of questions, if you just want to get the concept, that also you can tell me. You may give those details to me in the comment section, so I will see those and will try to make a video for you so that we can grow our family on YouTube, right? I really want to take this family through a long way. It's not just a non-serious video making that I'm trying to do. I really want to grow this YouTube family. I want most of the students who are interested in chemistry to get associated with me and benefited with me. And it's not just about your growth. It's also going to give me the growth that I seek being a chemistry teacher. With this, thank you so much for all the love that I'm getting from last few days. And I really think that your blessings will be showered on me in upcoming days as well. So I will see you in the another video with some more questions. Take care.